Hi guys, I'm Emily and today we're going to do an electron configuration problem. So make sure that you have a periodic table right in front of you so that you can look at it while we're going through this problem. The question is asking us to write the electron configuration for gold and chromium. Look at your periodic table. You will see that gold is in the 6th row of the periodic table. So we can start with the noble gas configuration. If you want extra practice, you can go ahead and do all the other orbitals up until your noble gas core. But if you already know it, you can go ahead and start at the noble gas configuration, which would be xenon in the case for gold. And then we have the 4f orbital, and those are all full. It has the 14 electrons in there, so 4f14. And then we hit the 6s, so then 6s2 and 5d9. Now, this is actually wrong what I wrote, but there's a reason why I wrote it that way. I want you guys to understand this. What actually happens with an element like gold, which is on the 9th group of the transition metals, is that one of the electrons from the s orbital gets promoted to join the d orbital. So what actually ends up happening is that one of these electrons comes to the d orbital, and we get a 6s1 and a 5d10. Now, because 5 is smaller than 6, we should write it this way. Okay? And the reason that this happens is because full or half-full orbitals are much more stable than empty or partially full orbitals. So in this case we have a full and a half-full orbital, so this is a much more stable configuration for the electrons in gold. Now this again applies to all the elements in the 9th row, on the 9th group of the transition metals. Now let's do it for chromium. The noble gas that comes right before is argon. And then we have, let's see, 3d6 and a 4s, 3d4 and a 4s2. Once again, this is the wrong one. This is what you might think is the actual configuration for chromium, but the correct version would be 3d5, 4s2, 4s1, and for exactly the same reason that we had gold. Once again, this is a half-full orbital, and so is this one. So it's going to be much more stable than a full and a partially full orbital. So that is, once again, we take one of the electrons from the s orbital and put it into the 3d5, into the d orbital. So this would be the correct configuration for chromium. So together, gold and chromium are two examples of the 4-9 exception rule. Which states that, a full or a half-full orbital is going to be much more stable than a partially filled one. So that is why we do these. So this is going to be for elements such as chromium and molybdenum in the 4th group, and for elements such as copper, silver, and gold in the 9th group of the D metals, the D transition metals. So if this doesn't make sense or you still have questions on it, please come to my office hours or come to the AEW session on Wednesdays, and I will explain this again to you. I hope this made sense, and thank you.